Okay, so we have Factoring Workshop Part 2. Okay, so we're doing Part 2. We're going to cover what happens, we've already covered the specifics of factoring, how to factor a trinomial with a is 1 and a is greater than 1, how to factor by, one of them is by grouping, how to factor the difference of two squares, how to factor a greatest common factor. Now the question is, what's my strategy when I don't know what kind of polynomial I have? Here we go. Method of attack. Number 1, arrange the terms in descending order according to the exponents. Meaning, if I have x cubed, that goes first. Then my x squared term. Then my x term. Then my coefficient. That's descending order. If I have a GCF, I factor it out. For example, if I had 2x squared plus 4x plus 6, I would factor out the GCF, which would be 2. 2x squared plus 2x plus 3. That's the second step. Descending order, GCF. Then I decide, what do I have left? I look at what I have left and how am I going to factor it? Here are my options. If I have 4 terms, grouping. If I have 3 terms, I've got 2 choices. I've got the case where a does equal 1, and then I just set up, remember, with this. X, X. Find the 2 numbers that multiply to C but add to B. That's when a is 1. When a doesn't equal 1, I use factor by grouping. Multiply to AC, what multiplies to AC but adds to B? Replace B of X, and then break into 4 groups, factor by grouping. So, and then my final option is, do I have, if I have 2 terms, is it the difference of 2 perfect squares? If it is, I may use this formula, a plus b, a minus b. Check again to see if there's any portion of what I've factored that can be factored further. Continue. Check by multiplying everything back together, and you should end up with the original polynomial or equation. Let's do 1 together. Look at number 4. First of all, the first thing I have to do is I have to put it in descending order. So that will be the x squared term first, then the x term, then the last coefficient. I look at that and I say, well, I have a trinomial with a equals 1. So I know I can set it up like this, x, x, and I think to myself, what multiplies to 45 but adds to 14? Well, I know there are factors of 45, 1 and 45. That won't work. 3 and 15. That multiplies to 45, but that won't work. 5 and 9. That is what works. So what do? I plug it in, plus 5, plus 9. And I am factored, and I have nothing, I cannot factor any further. Neither of those factor any further, so I am done factoring. So you see the steps, they're your general method of attack. Now please go and do these 3 problems for practice. You can stop the tape, we're going to move on. Alright, so we want to solve. The next thing we're going to do is we're going to solve. What do we do when we have these factors? Okay, this is method number 1 of solving. Okay, solving. We're going to learn 3 methods. This is number 1. We're going to use the principle of zero products. If a and b equal 0, which means if I have 2 factors, so a and b are going to be our 2 factors. If the multiplication of those equals 0, then either a equals 0 or b equals 0. So what we do is when we solve by factoring, we bring all terms to one side, like in this case, we'd make sure everything was on the left, factor the polynomial, use the principle of zero products, set each factor to 0, solve each resulting equation for the variable. Check. Okay, so let's do one of these. Let's do number 2. I have all terms on one side. This problem is already factored, so step 1 and step 2 are done. The principle of zero products says that either x equals 0, the first factor, or x plus 2 equals 0, or x minus 1 equals 0. This will give me my 3 roots. This is an x cubed polynomial. So we have this. This is solved. X is 0. We subtract 2 from both sides, and we get x equals negative 2. We add 1 to both sides here, and we get x equals 1. Now I have my 3 roots, zeros, intercepts of the polynomial. What does that mean? Let's just review what that means. If I had this graph, then at negative 2 and at 0 and at 1, at all of those points, negative 2 and 0 and 1, this graph would, sorry, that's really going through the 0. Okay, that's going through the 0. Intercept the x-axis at these points. That's what my zeros are. Okay? All right. You please practice the other 3 problems. Once you get factors, set them equal to 0 and solve for your variable. We're going to move on to solving by the square root method. When do you do this? When there's no bx, meaning x to the first power. X to the first power. When you only have one x, an x squared, you can use the square root method. Here's what we do. We isolate the x squared term. Sometimes that's just x squared. Sometimes it's x plus some number squared. Okay? Either one of those. We isolate it. Everything else to the other side. So let's do this for problem number 3. Let's do problem number 3. I want to isolate x plus 3. That's my x squared term. So I divide both sides by 2 to get rid of that 2. I have x plus 3 squared equals 8 divided by 2 is 4. My term is isolated. Next thing I do is, number up there, I take the square root of both sides. When I take the square root, what multiplies to itself to give me x plus 3 squared? Well, that would be x plus 3. These just cancel each other out. Equals the positive and negative 2. Square root of 4 is 2. 2 times 2 equals 4. Negative 2 times negative 2 equals 4. But I'm not done because I have this plus 3. So I subtract 3 from both sides. And I get x equals positive or negative 2 minus 3. And I am not done. I do not want to leave this like this. So what I do is I cover up these one at a time, and I say, I'm going to have 2 answers because it's a quadratic. What is positive 2 minus 3? Negative 1. What is negative 2 and negative 3? Well, that would be negative 5. So x is equal to negative 1 and negative 5, which tells me that I have a parabola at negative 1, negative 5, and it's going through the axis at those points. All right, go ahead and work through those other 3 problems. Bring them to class. We're going to go on and do our final method. The final method is called the quadratic formula. As we sang our song in class, now we're going to use it. When do we use this? This always works. You can always use it. It's necessary when the trinomial is not factorable, meaning there aren't 2 numbers that multiply to AC and add to B. There just don't exist 2 numbers that do that. That's when we use this for sure. So let's go through the method. What we do, put the equation in standard form. Standard form, you remember, is y equals ax squared plus bx plus c. And set it equal to 0. So just set it equal to 0. Now you're going to identify A, B, and C, and you're going to plug those numbers, they're all coefficients, into this equation. You're going to solve for x. Okay, there's going to be 2 answers because of the positive and negative sign, and you're going to check them. Okay, let's do problem number 3. So first I have to get it into standard form. I want to add this 2 to both sides. I need to get 2x squared plus 3x. These cancel. 7 and 2 is 9 equals 0. So I've set the equation equal to 0 now. There's no more greatest common factor I can take out. So identify I identify A is 2, B is 3, and C is positive 9. So now I'm going to plug it into my formula. X equals negative B, negative 3, plus or minus the square root of 3 squared minus 4 times A, which is 2, and C, which is 9. And I take the whole thing over 2 times 2, which is A. And now I just have to work it out. Well, I know that 2 times 2 is 4, so let's get that out of the way. Now the first thing I like to do is break this up. So I have this thing, the plus or minus, that's breaking up this fraction. So I'm going to take the first part, negative 3 over 4, plus or minus something else over 4. So I'm not leaving myself much room here. But I'm going to have 3 squared is 9. Now, am I going to add something or subtract to it from it? I have a negative and 2 positives, so I'm going to be subtracting. 4 times 2 is 8. 8 times 9 is 72. Okay, so I keep working the problem. And I get x equals negative 3/4 plus or minus the square root. Now when I take 72 minus 9, I get 63, negative 63 divided by 4. Okay, so I have a negative under the radical sign, so what do I know about that? This is the discriminant, right? B squared minus 4AC is the discriminant. When the discriminant is negative, I know I'm going to have 2 imaginary roots. And that's the situation we have right here. So what are we going to do? First of all, we got to get that negative sign out of there. So let's take 63. We have the square root of negative 63. We can factor that out. That is the square root of 63 times the square root of negative 1. But I can factor 63 again, right? What are the factors of 63? Well, how about there's one that's a perfect square, 9 times 7 times negative 1. So I can now simplify. I have 3, the square root of 9 is 3. I can't do anything with radical 7, and the square root of negative 1 is I. Okay, so I've got that simplified, and I'm going to pull it back into my equation. So this is x is going to be negative 3/4 plus or minus 3 radical 7I divided by 4. And there are your 2 answers. Negative 3/4 plus 3 radical 7 over 4I, and negative 3/4 minus this whole term. Okay, there you go. I want you to practice on these 4, 2, well, this should be, I don't know, I'm numbered all wrong, but these next 3 problems, and bring them to class and check the right answers. All right?